The GMAETS 41's academic firepower remains top-notch. You are welcome to our live stream class tonight. At least I was able to beat up time a bit. Now, what do you think? So tonight we're going to look at chemistry. Like I told you guys after our morning class, I told you we are going to deal with chemistry tonight, and we are going to be looking at solubility and introduction to organic chemistry. Good. So you are welcome to the class. If you join the class, give this class thumbs up as usual. No time to waste. And make sure you are sending this make sure you forward the link to this class to your friends, okay? I was actually showing the other end of my library, and I didn't know that the board hasn't displayed. But okay, I'm here now, like no time. I hope you had a wonderful day, your activities today, and I hope you're able to follow up with stuff that we learned in physics this morning, where we treated the concept of refraction. Please share this link to your friends, to groups that you may be part of, where students there are preparing for the forthcoming JAM and WAEC examination. Like I said, the GMAETS 41's academic firepower remains top-notch. No going back. All right? As we continue to receive the support and the strength from our helper and God Jehovah, you can always count on this channel. We're going to be looking at chemistry tonight, like I said, and you can see right here on the board, we are giving attention to solubility and introduction to chemistry. Like I said, this is a class you would not want to miss, and having joined, you're welcome. So if you can hear me, just indicate I can hear you. Indicate I can hear you so that I'll kick off the class right away. All right, indicate I can hear you. All right, Mary Cynthia, thank you for letting me know that you can hear. That being the case, we are going to kick off right away. As usual, a quick summary before we look at the questions we have, okay? A quick summary. First, I'm going to give the summary on solubility, okay? I'm going to give the summary on solubility. I hope we'll have enough time so that we'll look at introduction to chemistry, organic chemistry. We're going to look at some structures and stuff like that. When we talk about solubility, what actually comes to your mind? You must have heard of the word soluble. That's to say something dissolves in another. Usually we have solute. Solute. In this case of solubility, as we're going to study here in chemistry, the solute is purely a solid. The solute is a solid. And then the solvent in which the solute is dissolving is a liquid. So generally, you know that we have solutes plus solvent giving us solution. All right. So if this solute dissolves, if the solute dissolves in this solvent, you can say that the solute is soluble in the solvent. Now, I'd like to say this. When I give you a solid substance, say a salt, a chemical salt, and you add that chemical salt to a given solvent. It is true there are some solute salts that cannot dissolve in a given solvent, but the truth of the matter is, for me, I do not believe that there is no way something a little cannot dissolve. Even if that solid is not completely soluble, the truth is there is something that definitely will be happening in that mixture that we may not know. Okay, it is said that there is no process that is 100% efficient. So I believe that if I give you a solid, where we refer to it as a solid, and you add it into a solvent, some parts of that solid, no matter how little, will dissolve. And that is what brings in the concept of solubility. We want to find out the amount of that solid that dissolved in the given solvent at any temperature. Like I said, all of them must not dissolve. However, you can't just tell me that nothing at all will dissolve. Something, no matter how little. The point is that if maybe the quantity that dissolves is so small, we can neglect it and say that that solute, which is a solid, is insoluble. That does not mean that something did not dissolve a little. Is that okay? So that's what we try to study in solubility, where you have a solid, we shall be referring to that as solids, dissolving in a solvent. The solvent is going to be a liquid, in this case of solubility. Take note of that. And so I want to find out what amount, what quantity, what mass of the solid can dissolve in the solvent at a given temperature. So I want to believe you get the idea of what solubility is really interested in. Random duty. Hi from Russia. You are welcome. You are welcome. Please, this has nothing to do with how to get a girlfriend, please. This is purely an academic channel. Take note of that. So if you are here on how to get a girlfriend, please, you had better quit. However, I can still advise why look for that. Get serious with your studies. Let's get to business. Let's define the term solubility. Solubility. What is it? I've given a background. So define solubility as the amount of a solute which can dissolve in a given solvent at a particular temperature. The amount or the quantity of the solvent that the solute is to dissolve in, usually we quote it as 1 dm³. So we can go ahead to now define solubility, in more professional way, in more chemistry way, to be the amount of solute, the maximum amount of solute that can dissolve in 1 dm³ of the solvent at a particular temperature. Permit me to just write that on the board. This is defined as the amount of solute. Now that amount of solute can either be in moles or in mass. The amount of solute, let me indicate the maximum amount of solute that can dissolve in 1 dm³. 1 dm³ is the same as 1000 cm³. That can dissolve in 1 dm³ or 1000 cm³ of solvent at a given temperature, at a particular temperature. So you see that solubility is temperature dependent. Solubility is what? Temperature dependent. All right. We have known what solubility is. Your examiner would want you to know types of solubility. Okay, types of solution rather. your examiner would want you to know about types of solution. I remember I'm still owing a class on colloid. I'm going to host that class, okay? Just be patient with me. We talked about that in our last class. Because then when you talk about colloid, colloid is a type of solution as well too. Homogeneous solution is a type of solution. Then heterogeneous solution, also known as suspension, is a type of solution. But under solubility, the type of solution we deal with is dependent on something else. It's dependent on something else. It is dependent on the amount, the quantity of the solute that can dissolve. It depends on what happens to the solute in terms of its solubility at a given temperature. So for this, under solubility, your examiner wants you to know about types of solution. You want to take note of that. And in this case, the type of solution, please, is based on solubility, based on the amount of solute that can dissolve in a given solvent. In that case, like I said, this is dependent. Let me indicate. Dependent on solubility. Solubility. We have the following types of solution. Number one, we have that which we call saturated solution. Saturated solution. We have that which we call unsaturated solution. Unsaturated solution. And we have that which we call supersaturated solution. Supersaturated solution. Do you guys have galvanic cell in chemistry like we have? Yes. Random duty. We do have galvanic cell. Galvanic cell, also called electrochemical cell, right? You can also call it voltaic cell. We treat that under electrolysis and electrochemical cell, but that's not the focus of this topic now, okay? Now, these are the types of solubility, types of solution based on the solubility of the solute. Based on what I said, solubility of the solute, we have this type. Please, you want to take note, like I said, we also have other type of solution, which we call, homogeneous solution, yep, heterogeneous solution or suspension, and colloid. Homogeneous, heterogeneous, and colloid solution, these ones depend on the size of the solutes, on the size of the things you are mixing. But that is not the type of solution we are dealing with under solubility. You want to take note of that. Under solubility, type of solution which is dependent on solubility, we have these three. I'm going to define them quickly. Sadly, I won't be writing them on the board. So you follow up as I define them. Saturated solution. What type of solution do we call saturated solution? A saturated solution is that solution that contains a given amount of solute. A given amount of what? Solute in a solvent in the presence of undissolved solute particle. I take that again. Saturated solution. A type of solution which contains as much solute particles in a solvent in the presence of undissolved solute particle. So this type of solution, hey, right, it's a type of solution whereby you have the solvent, you have the solute, which is the solid, inside the solvent. The solvent contains that solute, contains some dissolved solute in the presence of undissolved solute particle. So someone can still define saturated solution, using the term. This is grammar. So based on the way you understand it, the idea here is that you have a solvent, it contains as much solute as it can hold at that particular temperature, but in the presence of undissolved solute particle. For the last time, let's define it and still here, right? Saturated solution is a type of solution that contains as much solute particle as it can hold at that temperature in the presence of undissolved solute particle. That is what saturated solution is. You can think of when you want to drink water. Okay, you start drinking. You definitely will reach a point called a saturation point, where your stomach is filled, as it could be, with water. You can't take more. But let us assume that you still have, the can of water there, and then you still take in some amount of water. But this time around, that amount of water is down in your mouth, because you can't swallow it. You can't take it down, since your stomach is already filled with water. And so you now hold the water, you hold it because you don't want to pour it out. Maybe you are thinking of the amount of money you use in buying the sachet of water, or in buying the can, the bottle of water. So you refuse. I won't pour this water away. I won't throw it away. So your stomach is filled. No room for further water to be taken in. But then you still have some amount of water in your mouth. It can't go out. It can't go in, and you don't want to pour it. So in that case, we say that if I say that your stomach is the solvent, it has now taken in solute, say the water, as much as it can contain, as much as it can hold at that time. But here we use the term at that temperature. In the presence of some of the water in your mouth, which cannot be taken in. That is what saturated solution is all about. Type of solution that contains as much solute particle as it can hold at that temperature in the presence of undissolved solute particle. I think I've spent time to talk more about saturated solution, so you get the idea. Then unsaturated solution is that type of solution that contains as much solute particle as it can hold at that temperature in the presence of dissolving solute particle. Underline that term, that key word, dissolving. So any type of solution that contains as much solute particles as it can hold at that temperature, but still in the presence of dissolving solute particle, or in the presence of dissolving solid particle. You can either use solute or use solid, like I said. That type of solution is called unsaturated. You see, that solution is not okay yet. It has not reached its maximum level. Yes, it contains some solutes that it has dissolved, but it still has room for other solute particles to continue dissolving. So you can think of a situation where you are so thirsty, you need lots of water. And then maybe you get a sachet of water, you took it, but you're not filled. You are not saturated yet. We say that you are unsaturated. In that case, you can still go and get another sachet of water or bottle of water and drink further. Because the one you took before is not yet enough for you. So that type of solution, which contains as much solute particle as it can hold at a given temperature or at that particular temperature in the presence of other dissolving solute particle, is known as unsaturated solution. So please repeat unsaturated solution again. I think I just repeated it. And one more time, I go over it again. Unsaturated solution, just underscore that term, unsaturated. It means it has not gotten to the limit where it will say, I can't take anymore. It has not gotten to that point. So the type of solution which contains as much solute particle at that temperature in the presence of dissolving solute particle is known as unsaturated solution. You notice that I used the continuous tense, dissolving, which means, yes, it contains some solute, but there are still other ones still dissolving in that process because that solution is not yet filled, it's not satisfied yet, it's not saturated. Let's talk about supersaturated solution. Supersaturated solution. Super. This one now is beyond what is expected. Right? So when something is supersaturated, it simply means, okay, it has attained that saturated level, but it still contains other dissolved particle. It has attained the saturated level, but it still gave room for further dissolution, for further solid particle to still dissolve. Does that make sense? So that is what we refer to as supersaturated solution. So in that case, this guy contains more than it can hold. Remember what I said? It has reached saturation, but it is still forcing itself to dissolve more particles. All right, let's look at the definition in such a way that any one of you may choose to put it down. A supersaturated solution is defined as that type of solution that contains as much solid particle than it can hold at that particular temperature. It contains as much solid particles than it can hold at that particular temperature. That is what supersaturated solution is. All right, guys, I hope you understand this concept of types of solution. In this case of supersaturated solution, if we still link it to the case of drinking water, there is this thing we do sometimes, just punishing ourselves. You take water, and then you're okay, but maybe you think that, I think I can still take more. I want to take more because I am going to a far distance, and maybe along the road, I might not see water to drink. So what happened? You take and take and take, and take more than is necessary to take at that time. Okay, so you'll be bloating. You'll be what? Bloating. Because your breath would not get down anymore. So in that case, you have taken more than enough water. Yeah, everything went in, no argument, but it is more than you could hold at that given time. All right. Let us move on, please. We are going to look at solubility curve quickly. Solubility curve. When you hear solubility curve, it is simply a curve that shows the relationship between solubility and temperature. Because the solubility of a substance, like I said, depends on what? Temperature. If a substance, let's say 2 grams of a substance can dissolve at 20 degrees centigrade. If you increase the temperature of that solvent, or maybe the temperature of the solution as a whole, the solute can still dissolve more. Are you following, right? The solvent can absorb more of the solute. So if maybe at 20 degrees centigrade, 2 grams could dissolve. If you increase to, let's say, 40 degrees centigrade, 4 grams may dissolve. If you increase to, let's say, 50 degrees centigrade, something like maybe 6 or 7 grams may dissolve. Are you following? So there is this idea for some solids, though, the higher the temperature, the higher the solubility. So your examiner may want you to take note of the relationship between solubility and temperature. And there we have this graph, relationship. Okay, let me just write it as solubility curve. Let me just write it as solubility curve. Solubility curve. So the sketch is just something like this. Then here you have your solubility, and here you have your temperature. Permit me to abbreviate temperature. The solubility is quoted in mole per dm cube. Mole per dm cube. Temperature here is quoted in degrees centigrade. you want to quote it in degree Kelvin, the choice is yours. So you may have values. Let's say this is 0, the origin. Okay, let me assume that this is 10, this is 20, 30, 40, 50. In your exam question, the sketch of the graph will be given to you, so it will be easy to trace. The temperature, let us assume we have something like 5, 10, 15, 20. And so you could have curves drawn this way. Let us say this one goes like this. Let's call this solute A, substance A. Are you following, right? It's a solid. You may have some go like this. Let me call this B. I might have a solid whose solubility just goes straight like this. Let's call this C. I can have a solid, perhaps the way the solubility behaves with temperature could be something like this. Let's say it goes this way and then something like this. Let's say something like this. Let's call this solute D. So you're being able to interpret this solubility curve is important. And what are likely exam questions that an examiner can ask you? You can be asked stuff like, at what temperature does maybe two solids, at what temperature? Do we have something like two solids having the same solubility? At what temperature? You can also be asked to maybe between two temperatures, calculate the amount of substance that can crystallize out. For example, look at this point. This is solute B. Look at it, solute B. This is solute A. Look at it, solute A. If I ask you at what temperature is the solubility of solid A and B the same? At what temperature is the solubility of the solid A and B the same? What you do is simple. Just come to the point where the two curves meet. And this is where both of them met. Let me use this shade of marker. Both of them met at this point. That is the two solids A and B. So at this point, they have equal solubility. They have equal solubility. If you want to get the solubility, what you would do is you take it that point where the two curves met, take it dot. At this point, you read off the value of the solubility. So you see, these two solids, A and B, they have the same solubility at this point. And the solubility value is here. You read it off from the vertical, from the solubility axis. This is just a little above 20, so we can just assume 22, just an assumption. 22 mole per dm cube, that is the equal solubility. Now, at what temperature do they have this 22 mole per dm cube solubility? To get the corresponding temperature, the temperature axis is your horizontal axis. So you take it down, dot. You know, my hand is not, this is freehand sketch, so it's not perfect. Now, let me assume that the temperature is 10 degrees centigrade. So it simply means that at 10 degrees centigrade, solid A and solid B, they have the same solubility. Like I said, if you add something like this in your system, the graph sketch will be given. Right? For example, you do the tracing on screen. Does that make sense? Some paper, fine, but you know, in Nigeria here, JAM is not written on paper, it's screen work, okay, CBT. All right. So that is in the same way you can be asked to find the solubility at a given temperature. Let us assume I ask you to find the solubility of let's say D, solubility of solid D at 20 degrees centigrade. Solubility of solid D at 20 degrees centigrade. What will I do? I'll come to 20 degrees centigrade on screen. Then you can just, maybe with your pencil, you follow the line, then take it to the solubility axis. So from 20 degrees centigrade, I will trace dot. Once it touches the curve representing that solid D, this is the curve representing solid D. What you now have to do to get the corresponding solubility of salt D, solid D, solute D. You know, these guys are salt in chemistry term. They are chemical salts. And these salts are solid. We refer to them as solids. So if I ask you to give me the solubility of D at 20 degrees, come to that 20 degrees centigrade, trace it up. Once it touches that curve that represents solute D, what you have to do now is take it to the vertical axis, which represents the solubility. So you see from here, dot, 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 somewhere here just close to 9, but before, close to 10 rather, but before 10. I can assume the solubility here to be 9 mole per dm cube. Like I said, the graph work will be given to you in your question paper or on screen, as the case might be, so you can do the traces accurately. Because in that system, it's drawn to scale accurately. Are you getting me? So from there, you read it off. At 20 degrees centigrade, the solubility of D is 9 mole per dm cube. Okay, now, what if I give you two solubility? Because your examiner can ask you, okay, get me the mass that crystallized, or the amount of the salt that crystallized between two temperatures. Let me pick solid B, this solute, salt B. Assuming that I ask you to give me the value of the mass of solid B that crystallized out between, let's say, 5 degrees centigrade and 15 degrees centigrade. What amount, what mass of solid B will crystallize, will precipitate out? Or use the term crystallize as it could be in the case of salt coming out of solution. I hope this has not cut off from screen. Let me see. Oh no, almost. Please permit me to adjust. Permit me to adjust this. Trying to adjust the camera to your view. Let's see. Okay, I think this is better. So at 5 degrees centigrade and 15 degrees centigrade, what mass or what mole of salt B crystallized out? You know, at 20 degrees centigrade, sorry, 15 rather, at 15 degrees centigrade, you can cool the solution of B. It's possible you can cool any of the solution of this salt. And when you are cooling the solution of the salt, usually it is expected that the salt will crystallize out for crystal salts. So in this case now, watch what you're expected to do. Between 5 and 10 degrees centigrade, if you cool the solution of B from 15 to 5, what mass of B will crystallize out? You come over to this, you dot. What you're trying to do is to get the two solubilities that correspond to 5 and 15 degrees centigrade. Get the two solubilities, take the difference. Once you take the difference, you have gotten the mole, you know, and you can convert the mole to mass, as the case might be. We've treated the formula used for that. So from 15 degrees centigrade, you take it to the curve of B. From there, to get the solubility at 15 degrees centigrade, you take it to the solubility axis, just close to 20. Please, permit me to assume here to be 18. Permit me to assume this to be 18 mole per dm cube. So it means that, okay, at 15 degrees centigrade, solubility of B equals 18 mole per dm cube. Then you come to 5 degrees centigrade and do the same thing. You dot it from 5 degrees centigrade to the curve of B, here. Then you take it to the solubility axis, So you see, above 20 but below 30. Permit me to assume here to be 27 mole per dm cube. So I can now say that at 5 degrees centigrade, solubility of B equals 27 mole per dm cube. Now, depending on the nature of the question, If they tell you the volume of solution B, you can now use solubility formula directly. You're going to see the solubility formula soon, okay? But if you are not given the volume of solution B, you are not given that, then you don't need to go and you don't need to use solubility formula to know the amount of B that crystallized out when you cool the solution of B from 15 to 5. What you now have to do, if you are not given the volume of B, there are some questions where you will be given the volume of B, other cases you might not. So assuming you are not given the volume of B, you don't need to use solubility formula. What you just have to do, once you have gotten the 2 solubility, take the difference. 27 minus 18 will give you what? 9, Abi? 27 minus 18 equal to 9. So between 5 and 15, if you cool the temperature of solution B from 5 to 15, the amount, because of course that's solubility, no argument. The solubility difference you're going to get will be 9 mole per dm³, which is still equivalent to simply saying 9 mole will crystallize out. And that 9 mole, remember, you can convert mole to mass. Remember, that is in the case you're not given volume. If you are given volume of that solution, you have to go through solubility formula, which you will now see soon, having explained this concept of solubility curve. All right. If you have any question, you can ask before we move on. And remember, you can always support the GMAETS 41's channel. You can support the GMAETS 41's channel. How can you do that? Just in that chat box, all right? That comment box you have, the chat box, just by the right, you will see currency icon. Please support GMAETS 41. Support this channel so that we will continue to grow and give you the best. Like I've always said or asked sometimes, am I not trying? It's not easy, right? Most of you are not channel members. Most of you are not. But I decide to give this out on the platter of gold to assist you people as much as I can. Remember, I need your support also. So if you click that currency icon, you would see super chat, you would see super thanks, and then you will see membership. For the super thanks and super chat, you can send us a one-time support. GMAETS 41 will greatly appreciate that. If you want to become a channel member, you can select from the platinum level and above, so you get much more benefit from this channel. Remember, you can contact me on WhatsApp. This is the WhatsApp number, GMAETS 41's WhatsApp number. Contact me and request to be added to the GMAETS 41's general WhatsApp group, where you get updates about our classes. And if you have a personal request, you can ask. Let's assume you want me to make a particular video. You can ask there, then I will have you in mind. And then we'll come online on YouTube here, I'll work on that to answer your question as the case might be. But remember, for that, you would have to become a channel member. From platinum level and above, you can also support us more and much more on diamond level. That is appreciated, okay? All right, Obiajulu, thank you very much for commending me. I really appreciate it. Thank you. Please, we are done with this solubility stuff. We are going to look at solubility formula. So run off what you have on the board. You can screenshot while I wipe the board, because we've got to move on to solubility formula. Finish up. Like I usually advise, you can screenshot. So at least you have a short note on this. I'll be wiping this part of the board, then we'll move on to solubility formula. After that, we'll now take questions we have on solubility. So what have we learned so far? We've been able to define what solubility is. We've seen the types of solubility, types of solution with respect to solubility. There are 3 of them: saturated, unsaturated, and supersaturated. We've defined each of them, given classical interpretation, using layman term with respect to drinking water to help you understand this concept of types of solution based on solubility. We've also analyzed the concept of solubility curve. It's a curve where solubility has been plotted against what? Temperature. It helps us to read the relationship between solubility and temperature. In the industry, this curve is being used a lot. For example, in pharmaceutical industry, where they manufacture drugs, right? They use this to check the solubility of certain substances which they mix up. Are you getting? During their production of drugs, because you know these drugs, we have stuff like liquid drugs. Okay, is it liquid drug? Liquid medicine, right? Liquid medicine, where, please take note, the drug I'm talking about, it's medicine. Oh, it's medicine. It's medicine. Please, it's not drug in terms of illegal stuff. Please, I'm referring to pharmaceutical industry where they produce medicine that we take in order to take care of certain sickness. So in the production process, the makers of this solubility curve to find, okay, this substance we want to dissolve in this solvent to manufacture this medicine. At what temperature will this substance dissolve the most in all those stuffs? They use that knowledge. So it's an interesting curve. It's an interesting curve. You know, I have to correct that issue of drug. I have nothing to do with drug, please. Take note of that. When you talk of drugs, it's just that in Nigeria, drug is also used to refer to medicine that we take for our health. Okay, please, let's move on. Solubility formula. The solubility formula is equal to mass of substance. I'm going to give you the overall formula that will help you see clearly the quantities contained in solubility. Mass of the substance all over molar mass times 1000 divided by volume. Now that 1000 is to convert the volume from cm cube to dm cube. So this thing you are seeing here is in dm cube already. This whole quantity is in dm cube. 1000 over volume. But the volume here, for you to have this 1000 over volume, this volume here will be given in centimeter cube. So permit me please to indicate where this volume is in cm cube. That is the reason why you have to multiply this whole formula by 1000 on top. Normally, let me show you the format of this formula is actually the actual format that made the 1000 to go up. It's mass over molar mass, then times 1 over volume. Now, if the volume is in centimeter cube, you now divide that volume by 1000. You divide it by 1000. You know, if volume is in cm cube and you divide it by 1000, it will convert it to what? dm cube. So let me indicate volume here is in cm cube. That's the reason you have to divide by 1000 to convert it to what? dm cube. Mathematically, you know, this is division of fractions, so this 1000 will go up. That's what gave us this. I hope you understand that, right? That's the reason for the 1000 to go up. And remember, it is in a case where the volume is in centimeter cube. So I'm going to ask you this question. Suppose the volume is in dm cube, not centimeter cube. In dm cube is the same as liter. Would you have to multiply this formula by 1000? No is the answer. So if you are given a question and in the question the examiner gives you the value of the volume and the unit of the volume is dm cube or liter, please take note. The formula will simply be 1 over volume. 1 over what? Volume. That's the standard formula of this guy. And this is the reason. Let's go further. This is the same as mass over molar mass is amount or number of moles. Amount or number of moles. Okay, let me say or moles. Mass over molar mass of anything is the amount of that substance. Is the mole of that substance. Times, you know, this thing, like I said, is 1 over volume. So depending on the unit of the volume, you can then decide whether to multiply this stuff by 1000 or not. So I want to say this. I know this formula might just be somehow, some way, because you hardly see these things I'm talking about in textbooks like that. Are you following, right? Most times the formula you see would appear like this. But I am telling you now, if the volume is not in centimeter cube is the same as ml, milliliter. So if the volume is not in that, not in cm cube, it's not in milliliter. Let's assume they give you the volume in cube, which is the same as in liter. This guy you are seeing here, 1000, won't be in that formula, which means that normally solubility formula is actually amount times 1 over volume. That amount times 1 over volume is simply amount over volume. And in fact, I'd like you to note, solubility is simply the same as concentration based on what I've just explained, because amount times 1 will give you amount divided by volume. So solubility is the same as molar concentration. Molar concentration. So you want to take note of this. And we know that molar concentration permits me to use C. We know that molar concentration, recall, molar concentration C is equal to number of moles divided by volume. You must have seen this formula before. You must have seen this formula. This formula is the same as this. But sometimes you see this formula to be multiplied by 1000 to give you this particular concept. That is based on the fact that we assume that the volume is in centimeter. But I always highlight this to students so that they will be aware of it. If the volume is in dm cube, this thing on the normal is not meant to be multiplied by 1000. No, it's not. The formula is simply number of moles over volume. Then you now have to wait to know the unit of volume that your examiner gives to you. That will now help you to know whether you have to multiply this by 1000 or not. Finally, I repeat again, if the volume is in centimeter cube, then you must multiply by 1000. Centimeter cube is the same as ml, milliliter. But if the volume is in dm cube, decimeter cube, which is the same as liter, then this 1000 will have nothing to do there. You don't multiply anything by 1000. So these are just practical stuff you need to know about solubility formula. All right, guys, we are moving on. Random Dide. Thank you for telling them this. So I'll read it out to you guys. He is a good guy for teaching you for free. In my country, this person connected to us from Russia, according to him. In my country, if you want class out of school, you should pay thousands of ruble. And I think Russian currency is ruble, or yeah, ruble. So you see, I'm trying, you know, I bet me not support to. Make I talk like Nigerian, make not support to, please. Now beg I beg. So that I'll not be pushed to start carrying out. I really don't want to do that, but I might be forced to do that soon, where my live classes will simply be for members. But let's help ourselves. My membership package is 2K. Yeah, 2K monthly. Now you pay, if you support the channel on membership level, 2,000 naira. That is just for a whole 1 month before you can renew. If you love what I am doing, nothing is there. You can do that, right? Just click on the join tab on the GMAETS 41's channel, or just right away you click on that that currency icon, like I said, and you will see that membership. Go on platinum level, at least understanding the economy. I have diamond level, which is 4K monthly. But if you go on platinum, I'm still okay. Nothing is there. I appreciate that. Okay, so that the ministry will continue to move. Anyway, thank you so much for helping us all to know about this. Appreciate it. Let's move on to. I think this is time for question now. This is time for question. We are done with this topic. Nothing is there. We are done with it. Let us look at some questions that we have here. Let's look at some questions. I think I've got some questions that GMAETS 41's JAMB and WAEC physical class students dropped. So I'm going to go through that. Finish up with what is on the board. And then because I'll wipe the board now clean. I'm going to clean up the board so that we look at the questions that we have there. Let's see how fast we can go. and then see if I can introduce organic chemistry. But if there is no time, there is no big deal. Tomorrow morning, remember I told you guys that being that JAM and WAEC is fast approaching, my aim is to see that you guys do well in this examination. And I've decided to pay the price, to sacrifice early morning, before you go to your activities and stuff like that. I will hold a brief class, even if it is 30 minutes to 1 hour. That's usually going to be by 7 to 8, or depending on my strength when I wake up, could be there about 6 a.m. to 7. So at least you guys will have enough time for some other things. Then in the evening, we'll still meet again. So let's see how far we can go with this. If I have enough time, we introduce organic chemistry. If we don't have, no big deal. We'll meet tomorrow morning. But all the same, I'm wiping this. Instead, I'm going to wipe this also because I want the board to be clean, right? So that we look at the questions that we have there. Finish up this so that I can wipe it. Trying to see, I am right there in our WhatsApp group to see the questions that one of the GMAS 41's group. We have there about 10 groups, and each group are tasked to supply questions, real-time exam questions, as they prepare for this examination. So we work on them online. And so I've got this question. I think this question is from group 7 of the GMAS 41's JAM students. There are about 20 questions. I know for sure we won't finish up. Okay, the 20 questions is inclusive of organic chemistry anyway, because I think they submitted both solubility problems and organic chemistry problems. Okay, so let us see how far we can go. Meanwhile, the organic chemistry is just the introduction. Our next class in chemistry, I'll be dealing with organic chemistry full. However, remember, on this channel, if you go to the GMAT 41's Chem 102, that is the code of that playlist, Chem 102. You will see video lessons, pre-recorded video lessons for you, right? Where organic chemistry have been dealt with fully. And I've been advising you guys, make sure you visit the channel. So go fully to where the video lessons are. It's not every time live. Sometimes to person the tire, all right? So you can take pre-recorded video lessons too. Okay, so we have this very first question here. I think question number 1. The solubility of alcohols in water. Question 1. The solubility of alcohols in water is due to A, their covalent nature. This question is actually meant to come under chemical combination. I don't really know why it was brought under solubility, but all the same, good enough. We've treated chemical combination, so that's chemical bonding. I can still give answer to it. The solubility of alcohols in water is due to A, their covalent nature, B, hydrogen bonding. That's good. C, their low boiling point. D, their low freezing point. E, their ionic character. Alcohols, when you hear them in organic chemistry, alkanols represent them. And the functional group of those guys is given as this, ROH. Between this oxygen and hydrogen, we have a bond. We have that bond. And that bond is called hydrogen bond. The hydrogen bond that exists between this oxygen and hydrogen bonding. Okay, hydrogen bond that exists between this oxygen and hydrogen is responsible for the solubility of alkanols, known as alcohols in the case of this question. So the correct option here is option B, hydrogen bonding. Option B is correct. Question number 2. 3.06 gram. This is calculation question. I'm going to dictate it. in our WhatsApp group, the questions have been dropped already. That's why I always advise you guys. I just don't understand what some of you are doing, but all the same, no problem. If you really want to be part of this channel and what this channel does, become full part of it. For all you guys going for JAMB and WAEC, listen, you will still go to advanced level university. The GMAETS 41's platform also covers university work of all universities in this country, even out of this country as it is. Are you following? You're in 100 level, 200 level, 300. There are works on the GMAETS 41's channel here, this particular channel that you're taking this live class on now. So you will still need this channel up to your 200-300 level. So why not become a full member of this channel? Become a member. You still have long way to go with this channel. And I hope I've not disappointed you guys, right? I've not. I've been up and doing, no matter what. So send a message to me on WhatsApp. This is the GMAETS 41's WhatsApp contact. Send a message and request to be added to our group. Please, if you are sending a message to me, indicate your name, where you are sending a message from, like your state of residence and your level of learning. Level of learning. Are you in secondary school? You know, that is high school. Are you in advanced level university? Are you following, right? Indicate so that I would know the group that you have to be added to. Because this channel have groups for different level of learning. Basic level of learning, secondary school level, high school, and university level. And once you are added to the group you are meant to be based on your level of learning, please do not be jumping up and down from one group to another requesting. I don't like that. Be in the group you are meant to be. You shouldn't be requesting for other groups. You have no business with them, right? Okay, let's move on, guys. We are looking at the next question. So I won't copy the question on the board. I'll just dictate. Because if you've already joined us, you could have gotten access to this question so that it is just for us to be solving. The time it will take me to write on the board, we'll be wasting it. Listen to the question. 3.06 gram of a sample of potassium trioxochlorate 5. 3.06 gram of a sample of potassium trioxochlorate 5 was required to make a saturated solution. Was required to make a saturated solution with 10 cm3, with 10 cubic centimeter of water at 25 degrees centigrade. At 25 degrees centigrade. At 25 degrees centigrade. First up, the solubility of the salt at 25 degrees centigrade is, the solubility of the salt at 25 degrees centigrade is, so we don't know, we've got the options here, 5.0 moles per dm cube, option A, B, 3.0 moles per dm cube, option C, 2.5 moles per dm cube, and then option D, 1.0 moles per dm cube. Now from the question, we're given the mass of trioxo, and you know you don't really need to declare your data in CBT case of examination. I've said this, I said it in the morning when I taught you the concept of refraction in physics. If you have your formulas upstairs, allow the solving sheet of your brain to guide you to avoid writing some things on paper where you waste that time. From the question, we know the mass already. Must I write maybe on my solving sheet if I am in exam hall, mass m equal to, I'll bring out the value. This is not theory. Except for those taking theory in WAEC, which is why sometimes I bring this thing out, because you need to be guided. If it's a theory question, you have to present your work formally, professionally. But for CBT cases, where you just select the option that is correct, you don't need all this declaration of data. But just because the question was not copied on the board, let me declare it. Mass of potassium trioxochlorate 5 given is 3.06 gram. And then the salt, the name of the salt is potassium trioxochlorate 5. That guy is KClO3. This is the salt. The reason is you need the molar mass of that guy. In fact, in the question, they gave us the mass of the relative atomic mass of each of these guys. But before then, let me write out the volume. Volume of the solvent is 10 cm cubed, 10 cubic centimeter. Then in brackets, we are given this K is equal to 39, of course, the relative atomic mass of potassium. Relative atomic mass of chlorine is 35.5. It was given in the question. And then oxygen, the relative atomic mass is 16. It was given. That is to help you calculate the molar mass of this guy. The question says you should solve for solubility. Please, I'll be using C to represent solubility. I've told you that solubility is the same as concentration. I hope you're following, right? So let us move on and see what we are going to do here. Since you are looking for solubility, remember solubility in terms of the formula is mass divided by molar mass. I'm using small letter m for mass, which is this guy, 3.06, capital M as molar mass. Now the volume of the solvent was given to us in cm cubed, so we need that 1000 in the formula here. So it's going to be 1000 divided by volume, the required volume here. I hope you're moving on, right? So we are looking for this. We know the values of all these other guys were given to us. We can calculate the molar mass of potassium trioxochlorate 5. I've taught you how to solve for molar mass. It's simple. This is going to be 39 plus 35.5 plus 16 times 3. 16 times 3 is 48. That 48 added to 39, then added to this. I think you should be getting 122 point something. I don't know. Right, let's find out. 39. This is 48. 39 plus 48 is 87. Okay, so if I have 87 and then I'm adding relative atomic mass of chlorine, which is 35.5, this is 0.05 here, 12, move 1 to this, 12, 122.5 grams per mole. That is the molar mass of this potassium trioxochlorate 5. So we know the capital letter M value. Substitute to calculate solubility. The mass given to us is 3.06. All over, molar mass is 122.5, which is the molar mass of the given salt. Multiply by 1000, divide by the volume of water, which is 10. You can reach out for your calculator, you know that system stuff. And then you multiply these guys, right? So what do we have here? This is going to be 3.06. So I'm going to multiply it by 1000. And then divide by, if you want to press the denominator, open bracket for it. Divided by 122.5 times 10 in the denominator, right? So this gave 2.497. 2.497. And that's what I got here. You can approximate to 2.5 if you so wish. Okay, you can approximate to 2.5 because this is 2.49. So this is approximately equal to 2.5 mole per dm cube. This is the solubility of potassium trioxochlorate 5. That's given in the question. Option A here is 5.0 mole per dm cube. Option B, 3.0 moles per dm cube. Option C, 2.5 moles per dm cube. Option D, 1.0 mole per dm cube. The correct option, of course, is B. That's the correct option. 2.5 mole per dm cube. I hope this makes sense, right? That's good. All right. There are some other questions I would like us to solve. All right. There's this particular one I encountered, although I don't know, I've not traced it out from what we have there. But I've got this particular question here. So let me get it from this. It is interesting. Technical question I'd like to solve for you guys. This, I don't think is part of what was sent, but all the same, you guys need it. Let's see that question. Where is it? Trying to search it out for you. Please, just a moment. Good. I've seen the question. So it reads, I'm going to copy the question on the board. Let's take it as question 3. It's calculation, that's why, and it's important you guys are aware of it. Let me copy the question on the board here and see what we've got. I guess I saw it a moment. All right. Still on potassium triacylchloride 5. Potassium trioxochloride 5 as KClO3 has a solubility of 1.5 mole per dm cube. At 45 degrees centigrade. On cooling this solution, to a temperature of 20 degrees, the solubility was found to be 0.5 mole per dm cube. What mass of potassium triacylchloride 5 was crystallized out? Now we have the options given. Option A, 1.00 gram. 1.00 gram. Option B, we have 10.00 gram. Option C, 12.25 gram. Option D, 122.50 gram. These are the options provided. So how do we solve this question? When I was interpreting the solubility curve, there was something I told you. A situation whereby you are told that, okay, a salt solution was cooled from one temperature to another temperature. What amount or mass of that salt will crystallize out? So this is a reflection of the question, but put in statement form. This question could have been given with the graph, the solubility curve. Are you following? Then you will not be the one to read out the solubility at 45 degrees, the solubility at 20 degrees. Which are these values? Then use it to calculate the mass of the salt crystallized. So it's simple to attack. There is nothing in the question. Now, when I was explaining that concept under solubility curve, I told you that if you are given the volume of the solution, like in this case, if the volume of the salt solution of potassium triacylchloride 5 was given, then we'll need to use the main solubility formula, which is mass over molar mass. And you know that mass over molar mass is number of moles. So you can just simply say number of moles times 1000 over volume, if the volume is given in cmk. But if the volume of the solution is not given, I told you to just simply solve straight using the word solubility. Remember, I told you solubility is the same as concentration. Another word, another term that can be used to define solubility is molarity. Molarity, or concentration in mole per dm cube. These terms are the same. They refer to the same quantity. Okay, now if you look at this question, at this temperature 45 degrees, the solubility was 1.5. At temperature of 20 degrees centigrade, the solubility was 0.5 mole per dm cube. The volume of the solution was not given to us. So we wouldn't have to punish ourselves talking about using full solubility formula. What I'll simply do in this question is as simple as take the solubility difference between 45 degrees centigrade down to 20 degrees centigrade, comma, the solubility is equal to, you take the difference. So it's going to be solubility at 45 degrees centigrade, which is 1.5. You know, usually for most solid salts, right? The higher the temperature, the more the solubility, the greater the solubility. As the solubility is directly dependent on temperature. I said that when I was setting out the foundation of this topic. That is why at 45 degrees centigrade, we had 1.5 mole per dm cube is solubility greater than that at 20 degrees centigrade. Mole per dm cube. Oh no, I'm subtracting like I said, so no need of writing the unit. So it's going to be minus the solubility at 20 degrees centigrade. When you reduce the temperature, you know, the dissolved solute, the potassium triacylchloride 5 that dissolved will now start coming out. So like it will become insoluble, or it will be getting to insoluble situation, insoluble case. That case is actually crystallization. It will be coming out of the solution. Initially it was dissolved. Now it is coming out as solid. You're seeing it. So say that the solubility will be reducing in that case. So the lower the temperature, the lower the solubility would be. So 1.5 minus 0.5. Now if you subtract this, you will get 1. This 1 is in the unit of mole per dm cube. This simply means on cooling the solution of potassium triacylchloride 5 from 45 degrees centigrade to 20 degrees centigrade, the solubility became 1 mole per dm cube, which is simply difference in solubility of the salt at that different temperature. Now we're not given the volume, so we'll assume that this salt was dissolved in 1000 cm cube, which is equivalent to 1 dm cube. Now if you think of the solubility formula, assuming you even want to use it, since the volume was not given to us and the solubilities are already in dm cube, 1 dm cube is 1000 cm cube, which means that the solvent you use there, the volume is 1000 cm cube. Just like in this case, the volume of the solvent we used, the volume of water was 10 cm cube. In this case, the volume was not given. You assume it to be 1000 cm cube. So that even if you decide to use the solubility formula, the volume will be 1000. 1000 divided by 1000 will go off. Then you now have your concentration equal to mass over molar mass. That is why in this case, I just simply made use of their solubility traits. And this was the solubility difference. I will now tell you the interpretation of this. Listen. This simply means that in every 1 dm cube, or in every 1000 cm cube, the amount or the number of moles of potassium triacylchloride 5 that will dissolve or that will crystallize out between 45 degree and 20 degree will be 1 mole. I repeat that. For every 1 dm cube or 1000 cm cube, the amount, the number of moles of potassium triacylchloride 5 that will crystallize out will be what? 1 mole. That is the meaning. So this value you obtained here is simply your amount, your number of moles of this salt that will come out, that will crystallize from the solution. But for 1000 cm cube, take note, if the examiner gave us a specific volume here, we would have been forced to use this formula for each of the cases. For this 1.5 mole per dm cube, we'll use this formula to calculate the amount that will be crystallized out. Again, at 20 degrees centigrade, using this solubility, we'll still come back to this formula and calculate the amount. You know, mass over molar mass is amount, number of moles, and calculate the number of moles that we crystallize out. So when we get the number of moles for these two different guys, we'll now do the subtraction. Like I said, in the case the volume is 1000, that's why it didn't reflect. They didn't give us any volume. So even if you use this guy, fix the 1000 here, you divide. This will go off. The concentration, which is the solubility, will still remain that value given to us. So you now take the difference between them. So now that I know that this is 1 mole crystallized out between that 45 and 20 degrees centigrade, all I have to do now is to convert this to mass, because in the options given to us, the options were provided in mass. Option A was given as 1.00 gram, option B 10.00 gram, option C 12.25 gram, option D 122.50 gram. So I will convert this mole. This thing simply means, or it implies that the number of moles is equal to 1 mole. 1 mole. 1 mole in every 1000 cm cube or 1 dm cube. Therefore, to calculate the mass now, the mass crystallized. So mass crystallized will be equal to, remember, number of moles is mass over molar mass. You can see it here. This thing is equal to number of moles, small n. Therefore, to calculate the mass, you cross multiply. Mass will be number of moles times the molar mass of that substance. And we know that the number of moles is 1 times molar mass of the substance. The substance is potassium trioxochlorate 5. Thanks to goodness, we have it here. And the molar mass of that guy, I've wiped it, is 122.5. But you can always calculate it. Potassium is 39, chlorine 35.5, oxygen is 16. So you multiply by 3 atoms. Add everything together, you will get 122.5, which is equal to 122.5 gram. So this is the mass of potassium trioxochlorate 5 that we crystallize out. And from the options provided, the correct option is option D, 122.50 gram. 50 gram is still the same as 5. That is 0.50 gram is still the same as 0.5. So the correct option is option D. All right. So where are you from? Well, country, Nigeria. Country, Nigeria. State, Ebonyi State. You want to know the local government? Afikpo North. All right. So that's where I am from. But I reside in Anambra State. I reside in Anambra State. Okay, we are done with this particular concept. We are done with that question. And I hope that you guys understand what is on the board. Kimbolo, like, he's more than good. Thank you to all of you. Thank you to all of you. We give the greatest thanks, all the glory, the honor, and the praise to our God and helper, Jehovah, who makes this happen. All right? So we thank him. It's not by my power that all of this is happening. He's always there to support us, knowing my determination, my commitment to ensure that I give you friends the best, knowing what is happening in our education system. Sad to say, our education system is really going down, 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 and down. A lot of things is affecting it. Talk economy, talk the way school honors and other things. Other people, they are handling the system of education. I don't know. I feel like the only way I can contribute my quota to you guys is having my online platform always at high alert. Yes. All right, guys. We are done with this particular question, and I think we have to move on, right? So, is the primary group 2? No, I have a primary. Okay, how do I put it? I actually refer to that as basic class. So, primary school channel. That serves pupils from primary 4 to 6, students from JSS 1 to 3. Yes. However, for your English language, like tomorrow in the morning, we are going to hold a revision class on English language. English language is specifically on that basic class channel, not on this channel. This particular channel takes care of scholars from SS1, SS2, and SS3. That is high school grade, grade 10, grade 11, grade 12, then advanced level, 100 level, 200 level, 300 level. This channel is specifically for them. Okay? Then English and basic level of learning is in the GMAETS for the ones basic class channel. Yeah, you can always type it and check through. GMAETS for the one basic class channel. What time is the class tomorrow? It's going to be in the morning by 7 o'clock a.m. Nigerian time, God's willing. All right, it's going to be in the second channel. Like I said, the second channel is GMAETS 41. All I write it, GMAETS 41 basic class. GMAETS 41 basic class. That's the name of the channel. So if you type it on YouTube, you'll see that. Do well to subscribe, right? You can also use that channel to actually coach your younger ones. You can. The wonders of basic approach to learning that I presented in that channel is top-notch. I must be honest. And like I said, all the glory goes to our God and Father, Jehovah God. Just subscribe to it, okay? Make sure you follow through. Okay, I think with this, we have done some good stuff on solubility, and time is not our friend. Let's see how far we spent. So even if it's just to show you one structure, this is 121. Okay, let us say within 1 hour, 30 minutes, let's be done. So assuming, I think we're going to put it to a close in solubility here. If you have any question on solubility, feel free to send it across. Like I said, how can you easily do so? Well, you can drop the question in the comment box. Maybe after this lesson, after this live class, you drop the question in the comment box. All the comments that is being made, I think I know, yeah, likely all of them will disappear at the end of the live class. So if you want to still drop a question, you can drop it in the comment section below this live stream class at the end of the class. But for your good and to make it easy for you, send a message to GMAETS 41's WhatsApp contact. Request to be added to our general group, to the GMAETS 41's general group. Then there you can make your request. You can ask questions, which I'll bring to YouTube, yeah, because it is the platform for learning, and deal with it. Don't forget, please, you have to become a channel member. I really appreciate. Support the GMAETS 41. Like I said, right now in the comments or in the chat section of this live stream class, you have, I think, the currency icon there. Tap on it. If you click it, you would see stuff like super chat, super stickers, super chat, membership. You can send GMAETS 41 one-time support using the super stickers, using the super chat, whatever in the amount that is convenient for you. Then to become a channel member where you follow fully all we're doing, you can become a member. You have the membership tab there also. Then, you know, go for the platinum level so that you would benefit the more. All right, guys. So I will be wiping the board, finish up what is on the board here. I'll just introduce organic chemistry briefly, then we close. I'm targeting 1 hour 30 minutes. This is already 1 hour 24 minutes gone down. At least we've treated the concept of solubility. The truth is, exam questions that you might be asked would still rally around what we have covered so far if you are tested on solubility. Like I said, if you see any other stuff that you really need me to work on solubility, or you need my response to it, of course, I'm here for you guys. You can contact me on WhatsApp. So that's that. Let's wipe this from the board. And then just a brief introduction to organic chemistry. What I'm going to do, I'll just list something quickly for you. That stuff I'm going to list is a key concept of organic chemistry. That for any student, your first step into organic chemistry is to ensure you understand that stuff I'm going to do. At least let me do that before we conclude this class. That will now set the stage for our next chemistry class. I will update you guys. I cannot tell you the next chemistry class yet because tomorrow we won't take on chemistry. I don't think so. I think I'll be coming on live on mathematics tomorrow. Jam and white maths. Are you following? Yeah. Tomorrow, we'll likely look at the concept of differentiation, questions on integration, questions on matrices. So you want to be prepared. That's going to be tomorrow evening by 8 p.m., 9 p.m. You will get a notification on that. Make sure you subscribe to this channel. Turn on the notification bell so that if at all for any reason, like I said, you are not in our WhatsApp group, if I kick off the class, you will be notified by YouTube. All these things are necessary. They are necessary to follow up this channel and what is happening. Okay. So organic chemistry. As a quick introduction, first of all, I want to answer the question, what is organic chemistry? When you deal with organic chemistry, it is a chemistry that studies carbon and its compound. That studies what? Carbon and its what? Compounds. But please take note. When we talk about organic chemistry studying carbon and its compound, it does not include the oxides of carbon. The oxides of carbon, which it does not include, are carbon 2 oxide called carbon monoxide, carbon 4 oxide called carbon dioxide. Organic chemistry does not study these oxides of carbon. Organic chemistry does not study trioxocarbonate. It doesn't. So these guys, this group, CO32 minus, it doesn't. Sodium triosocarbonate 4, calcium triosocarbonate 4. These are compounds that contain carbon. Organic chemistry does not study them. And that's not all. Organic chemistry does not study carbon sulfide. Organic chemistry does not study carbon sulfide. It doesn't. Is that clear? So when you define organic chemistry as a chemistry of carbon and its compound, you must always attach with the exception of oxides of carbon, trioxocarbonates, and carbon 4 sulfide, because organic chemistry does not study them. Now, like I said, this is just a brief introduction. So when you talk about this quickly, organic chemistry being a chemistry of carbon and its compound, we have classifications of organic compound. Organic compounds are classified into 5, but I will not go deep into them. I'll just list them. Are you following, right? I'll just list them. 1, we have that which we call aliphatic compounds. Aliphatic compounds. Remember, classifications of organic compounds. How many are there? I said 5. Should I write them for you on the board? We have aliphatic compounds. Like I said, I have a wonderful video lesson on this concept, so that's why I just want to rush it. Slide through to the GMAETS 41's playlist. You check on Chem 102. That Chem 102 playlist is specially dedicated to organic chemistry. So aliphatic compounds. This is a classification of organic compounds. We have that which we call alicyclic. Alicyclic compounds. This is where you have stuff like cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane, and they fall under this. You could still have alicyclic which are cycloalkenes, because under this we have cycloalkane and we have cycloalkenes. But in most cases, cycloalkanes are more pronounced. Aliphatic. These are usually straight chain compounds. They are straight chain compounds. This is where we have alkanes, alkyne, and the rest. Please permit, let me top up my petrol a bit because the generator wants to go off now. Let me see if I can beat it up. I'll be back. All right, so I was able to beat it up. Okay, but I took risk because the generator was still on when I tried to add petrol to it. That's really dangerous. It's really dangerous. I don't want the screen to go dark to you. It had happened to us once, and I already liked the experience. I hope I won't try that next time. Okay, we are moving on. We are done with solubility. Take note. Someone just asked that. Take note. We are done with solubility. The basic things you need to know about solubility, we've highlighted them. So we are talking about organic chemistry, just the introduction. That's what we're going to look at. We are looking at organic chemistry. The introduction. I hope you can hear me right. Okay, so back to this, I was talking about aliphatic compounds. The moment I was pausing, I was trying to, hear the sound the gem was making so that I can go for a rescue. Under these aliphatic compounds, that's where we have straight chain hydrocarbons like alkane, alkane, alkyne. Of course, we also have other ones, the alkanol, the alkanoic acid, they all fall here. Alicyclic, I've told you, the cycloalkanes, the cycloalkenes, they are there. The third classification of organic compounds, we have aromatic. These ones are based on benzene ring. They are based on benzene ring. Then we have that which we call heterocyclic compounds. Heterocyclic, they are cyclic in nature. The only thing is that in the cycle, right, there is a part where you have an atom which is not carbon. All these other ones you have, it is carbon linked to carbon linked to carbon. This is straight chain. Aliphatic compounds are straight chain. Alicyclic, they are cyclic compounds. They are cyclic compounds. They are not open chain. They are cyclic. But they are not benzene, as in they are not aromatic in nature. Aromatic are also cyclic. What differentiates aromatic from alicyclic is that aromatic, they are based on benzene. Benzene ring must be there. Heterocyclic, I've just told you. In all these cases of cyclic, because this one is cyclic, this is cyclic. What you have there is carbon linked to carbon linked to carbon linked to carbon. But in this heterocyclic, carbon linked to carbon linked to carbon, then one of the atom is not carbon. One of the atom in that cycle is not carbon. That guy that is not carbon is called a heteroatom. Then the fifth classification is, I think, polycyclic or polynuclear. Polynuclear compounds. You can also call it polycyclic. Again, it is cyclic, right? These ones are obtained, they kind of further linkage of aromatic. If you have benzene ring linked to another benzene ring, two or more benzene ring linked, they form polynuclear or polycyclic compounds. Examples we have here like naphthalene, anthracene, phenanthrene, the rest of them. So these are the classifications. Now I'd like us to talk about hydrocarbons quickly. Hydrocarbons. If you hear hydrocarbons, hydrocarbons is simply a chemistry of carbon and hydrogen only. Hydrocarbon. Chemistry of what I said, carbon and hydrogen only. That is what hydrocarbon is. So you want to take note of that. Hydrocarbon. Chemistry of carbon and hydrogen only. And hydrogen only. So you take note of that. For organic chemistry, if you're talking about organic chemistry, yeah, you are studying carbon and its compound. But it's not carbon and hydrogen only. Like under aliphatic, for example, I told you there's something like alkanols, alkanoic acid, they are among aliphatic compounds also. Alkanes. Now, alkanoic acid contains oxygen in it. What about amines? Amines, that is alkyl amino alkanes. What about something like amides? Some of these might sound a bit new or odd to you because you are yet to go into certain level in organic chemistry. We'll come into all of those I'm just trying to tell you the organic compounds generally go beyond just studying carbon and hydrogen. But there is part of it, there is this one that focuses on carbon and hydrogen only. And that one is hydrocarbons. That one is what? Hydrocarbons. Assuming your examiner asks you the group of organic compounds that are hydrocarbons, what would be your answer? Group of organic compounds that are what? Hydrocarbons. There are 4 of these groups that are hydrocarbons. These guys, they contain only carbon and hydrogen. The groups that are hydrocarbon include hydrocarbon groups. Hydrocarbon groups. They include alkanes. Alkanes are identified by something like this, single bond. That's the functional group, and they are saturated. So you take note of that. Alkenes are identified by this. Their functional group is double bond. Alkynes, their functional group is triple bond. Then we have this other hydrocarbon, aromatic. They are hydrocarbons. Aromatic are what? Hydrocarbons also. And specifically, when you talk about that aromatic, benzene comes into play. Benzene comes into what? Play. Because benzene is this guy, you know. This is the structure of benzene. So you can see that what you have, one carbon is meant to be surrounded by 4 bond lines. One carbon is meant to be surrounded by how many bond lines? 4. This carbon, there are 2 bond lines around it, so we need 2 more. That 2 more, hydrogen will fit in. The same thing here, carbon is surrounded by 2 bond lines, so extra 2 bond lines will come with hydrogen, and that's what happens all around. So this is benzene. There is this form you can still express benzene where you have something like, let me squeeze it here. You have something of this form. This is called the Kekulé structure. Kekulé structure of benzene. I've written out the full structural formula. You know, in this case, there's this thing we usually see in benzene like double bond, and unfortunately, benzene is not unsaturated. Benzene is not unsaturated hydrocarbon. Take note. Benzene is considered saturated because that stuff we see in it like double bond. Where will I squeeze it and show that? Let me squeeze it here. Something of this kind. Something of this kind. This is not benzene. I'm sorry about this. Oh my gosh. But it is good I made this mistake. It is good I made this mistake. But I'm sorry, this is not benzene. This is cyclohexane. So this compound actually falls under alicyclic, the 6th member of this guy, cyclohexane. This is not benzene, please. I'm going to wipe it. Though the structure looks alike, but the distribution of the number of hydrogen there is wrong. So look at it. Let me try to squeeze. Benzene. So here, something like double bond, single, double, single, double. But I'm telling you that this guy is not actually unsaturated. Alkenes and alkyne that have double and triple bond, they are unsaturated. This stuff you're seeing here, this bond that you're seeing like double bond is not actually double bond. This bond rotates around the link. The double bond can come here, while the single bond shifts to this place. This double bond can come here and the single bond shifts here. And this double bond can come here and the single bond shifts here. So you see that that stuff that looks like double bond is rotating. It's actually as a result of delocalized electrons. For that reason, we don't consider benzene as being unsaturated, even if it has something like double bond, right? It is actually considered saturated. Now, one carbon atom is meant to be surrounded by 4 bond lines. That's what I told you. This one now has 3 bond lines, so it needs 1 more hydrogen to complete. This has 3 bond lines also, 1 more hydrogen to complete. The same thing all through. So this is benzene. which is written as C6H6. C6H6. 6 carbon atoms, 6 hydrogen atoms. So that's it. That's it. And this structure, because the double bond can rotate, can move from one link to one carbon to the other, we can simply represent benzene with this structure. Okay, so we'll try to round off quickly. I think I've shown you certain things about the stuff you need to know. These are the 4 main groups of hydrocarbons. When you come to them, what you will always see are carbon and hydrogen. So this aromatic benzene is one of the key compound there, or key member there. It's all right. I'm going to wipe this. I told you that there is one of, the most important thing you should know when dealing with organic chemistry. And that is what I want to list for you now. We are supposed to define something like homologous series, but don't worry, you can go learn that or go straight to the playlist on Chem 102. If you go to GMAETS for the ones playlist on this channel, scroll, you see Chem 102. Click on that Chem 102 playlist. The video lessons there will open. Scroll through, you will see organic chemistry video lesson that focuses on this introductory part. Definition of homologous series, functional group, they are there. Please, I want to hit the main thing of interest now. And the main thing of interest is for you to know the functional group of each member. As you're preparing for your work, for your jam, there are these homologs whose functional group you are meant to know. In advanced level, like those in 100 level, we actually study up to, there are about 14 or 15 of the homologs. But for O level, your work and jam, think you don't cover the whole 14. But let's see, I might just list the functional group of the whole 14 anyway. So here I would have homologs, and I'll have functional group. You don't joke with functional groups, please. Functional group is like surname. Functional group is like what? Surname. You don't joke with them. The functional group helps you to identify a particular homolog. The functional group is a bond or group of atom. I'm trying to define it for you now. Functional group is a bond or groups of atom that determines the chemical identity and chemical reactions of a homolog. The first member of the homolog that any student who wishes to understand organic chemistry, the first member you must start with, I repeat, you must, it's a must. Many students end up saying that they do not understand organic chemistry. I really don't know, but I think from my own personal years of experience, at least there are about 22 years of teaching or so now, if I'm not mistaken, right? Close to 22 now. Yeah, close to 22, or at least 18, 19, 20, yeah. So within that range. From my personal experience, the only reason for why students or a student may have challenge with organic chemistry is one, not knowing what functional groups are, not knowing the homologous series and the members of homologous series. These two guys are extremely important. Extremely important. Once you're able to capture them, the problem in this course is as reduced as high as 70%. So you don't joke with what I'm about to list on the board now. The first member of the homologous series is alkanes. And how do you identify alkanes? The functional group of this guy is single bond, like I told you from here. Number 2, alkenes. The functional group is double bond. Number 3, alkynes. Alkynes, the functional group is triple bond. Number 4, alkanol. Alkanols. The functional group is something like this, OH. This R here represents long chains of carbon. Actually, we refer to this R as alkyl. Alkyl. An alkyl is an alkane. An alkyl is an alkane. Look at it, alkyl. That's how I pronounce it. Actually, the main pronunciation of this guy is alcohol. Alcohol, but let's leave the pronunciation yet. So Some people pronounce it alkyl. It's okay as long as you know what you are referring to. I've told you the correct pronunciation, alcohol, but I'm not interested in that. Alkyl. An alkyl is an alkane that has lost one hydrogen atom minus one H. So if you have any alkane and you remove one hydrogen, what you're going to get is alkyl. So anytime you see this R in organic chemistry, it is used to represent alkyl. Alkane that is short of one hydrogen. So that's the functional group OH. You can write ROH, but we usually use OH as a functional group of alkanol. Number 5 is alkanoic. Okay, alkanal. Alkanal. Functional group of alkanal is CHO. CHO. You can still expand this CHO as, can expand it as something like this. Let me see. I hope this part is showing on the screen. Let me see. See, can expand it like this. I'm trying to check that this part is showing. Let me take it forward and see what happens. It's not showing up here. Good. So you can, in expanded form, the functional group is carbon linked to this oxygen with double bond and carbon linked to this hydrogen with single bond. Don't forget this concept of how we get alkyl, because under IUPAC nomenclature, alkyls can be used as attachment, substituent also. All right, number 6 is alkanone. Alkanone. Alkanones are also known as aldehyde. No, alkanones are also called ketones. Let me indicate it. Ketones. Yep. Then this one, aldehyde. Aldehyde. You must cram. Let me just be honest. You must cram. Memorize this thing that I'm listing on the board now. It's a must to appreciate and handle organic chemistry easily. Once you grasp this concept, if you get it, your problem in organic chemistry is as good as solved. I must tell you that. Any other person can tell you otherwise, but I'm telling you the honest truth. You just get this and then wait and see what follows up in the course or in the subjects. So the functional group is this guy, C, and then okay, CO and then R prime. COR. This is the functional group. In expanded form, we have it like this. In expanded form. I think this point, we actually have R here and then something of this kind. Because hydrogen can never enter here. This bond, hydrogen can never enter it. You just have another alkyl there. So that's the functional group of that guy. For this alkanal, I can put an empty bond here. That empty bond shows that hydrogen or any other atom can enter that position. But in the case of alkanone, nothing can enter this position other than alkyl. So these are carbon chains, carbon chains. Okay, this takes us to alkanoic acid. Alkanoic acid. What is the functional group? Alkanoic acid is also called carboxylic acid. Like I said, these are surnames. Functional group, carboxylic acid. Functional groups, you don't joke with them, you have to memorize them. So get to look at them. Okay, so if I say everything, single bond between carbon atom, that is okay. Yes. Oh, so if I see between a carbon atom, maybe just somewhere, even if it is only in one place, you see something like double bond. That compound, the homologue is alkenes. Okay, imagine I give you something like this, C, and then something like this, C. I'm here to complete this whole thing, but just look at this. Which compound do you think would be this? These are now alkyne because of this triple bond between this carbon and carbon. So even though we have single bond, the presence of the triple bond makes it an alkyne. If it is double bond, it becomes alkene. If this is single bond, you now see everything between the carbon atom, the bonds are single. We call it alkane. What if I put OH somewhere here? The OH indicates that it's what? An alkanol. What if you see something like, let's say, CHO here? The CHO shows that this is an alkanal. Alkanal. What if the compound becomes something like this, C, and then double bond to oxygen, and then C this way? If you notice, this guy you are seeing are chains of carbon, which you can use alkyl to represent a chain of carbon, another alkyl, linked to this carbon that bears this oxygen with this double bond. Look at it. Carbon bonded to this oxygen with double bond, then single bond here to chains of carbon, single bond here to chains of other carbon. That is what we have here. So this represents alkanone. So you see how you identify this homologs. So once a structure is given to you, you can easily deal with it, knowing what that homolog is. Alkanoic acid is identified by this functional group, COOH. Whenever you see an empty bond line, it means that either hydrogen can take that position or other chains of carbon can take that position, which we refer to as alkyl. Alkyl. If you expand this, you are going to see something like this: carbon, double bond to this first oxygen, and then single bond to this OH, then empty bond. We are moving on. Okay, please, you can copy out or screenshot this. Don't joke with what I am doing right now. This is the beginning and close to the end of organic chemistry. Once you capture this thing, your problems in organic chemistry is as good as solved, like I said. Believe me, I'm telling you the truth and nothing but the truth. When we are done with this, you will see subsequent classes in organic chemistry. You see how the stuff will be going. This is your starting point. You don't play with this. It's not all about, are you pack nomenclature? What are you pack nomenclaturing? You know? What are you pack nomenclaturing? When you don't know the functional group of those guys, you forced me to say something I don't know what I'm even talking about. You know? So copy what is on the board there. You can screenshot, like I said, so that I'll wipe it off. Let's round off. We are almost into 2 hours. I thought I was going to be done by 1 hour 30 minutes. But all the same, we are not wasting time. So I'm going to wipe this now. $100 students of whichever higher institution you are, take note, in your organic chemistry, you must do this. So this is also for you. We are moving on. The next functional group of interest after alkanoic acid, that's number 8. This number 8 is actually a derivative of alkanoic acid. It's obtained from alkanoic acid. These are the ones we call esters. We call esters. The esters can also be called alkanoids. You can also call them alkanoids. 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 All right. So what's the functional group of this guy? The functional group is COOR. COOR. This empty bond line, like I said, once you see that empty bond line, it means either hydrogen or other chains of carbon, alkyl, can take that position. You can expand this if you want. You have something of this kind. The first oxygen is doubly bonded to the carbon. Then I have your OR. This OR actually comes from alkanol. Actually comes from where? Alkanol. Because to form esters is a reaction between alkanols and alkanoic acid, a process known as esterification. Don't worry, we are coming to all of those. We have other derivative of alkanoic acid, but sorry, because of the level I'm actually targeting, which are talk about those preparing for JAM, and then we'll talk about those preparing for WAEC. I wouldn't go ahead to mention acid amide acid chloride, then acid anhydride. I wouldn't mention them, but I've said something about it. I've mentioned them rather, but I won't write them on the board. If you want to learn about these other three I mentioned, acid amide, acid chloride, and acid anhydride, you can go to the GMAETS 41's playlist for Chem 102 on this channel, and then you can go through the functional group of these three I mentioned. At this point, I'll just move on to halogenoalkane, halogenoalkanes. Okay. For short, we call them haloalkanes for short. Take note. The functional group of these guys is simply RX. RX. R are chains of carbon, like I said, alkyl, and then X. This thing is just like, you know, I told you that alkyl is alkane that has lost one hydrogen. But if you notice something now, the alkyl, one X has come in. So it means that, okay, like you have an alkane, and then one hydrogen has been removed from the alkane, and then X replaced that one hydrogen. Those compounds, those homologs are called halogenoalkane. Take note, X is equal to either chlorine or bromine. Majorly in organic chemistry, that X as a halogen, that X represents halogen. Take note, that X in organic chemistry represents what? Halogens. But specifically, the halogen we usually encounter in organic chemistry is either chlorine or bromine. We are moving on. So you've seen the functional group. So imagine that I give you something like CH3, CH2, CH2, and Br like this. This is halogenoalkane. Halogeno what? Alkane. Like this now, the name is 1-bromopropane. 1-bromopropane. Or you can call it propyl bromide. Propyl, where you pronounce the alkyl first. 3 carbon atom, propyl bromide. Or for those of you that pronounce that alkyl alkyl, this will be propyl bromide. But if you want to pronounce the halogen before, you pronounce it as haloalkane. In that case, this will be bromopropane. Bromopropane. So depending on whichever you want to pronounce first, whether the alkyl or the halogen. All right, which other homolog is of interest? We have other homologs, like I said. We have nitrides, but I wouldn't list that here. I've told you my reason. The class I am focusing on actually in this live stream. For those in advanced level, you add up to your knowledge. Take note of that. I've listed about 3 functional group of homologs. I am not listing here. Nitrides are also part of those you are meant to learn, those in advanced level, but for your WAEC and JAM, you don't need it for those going for that exam. Then, of course, the amine group, amine, but you don't need that. The amine, they are written like this, but those going for JAM and WAEC, you don't need that. So I think these ones are cool. They're okay. These are the ones that the examiner wants you to know as you prepare for your WAEC and JAM. So what are you going to do for the GMAETS 41? I am giving you, if I say 24 hours, that's one day, but it's not too much. You're preparing for exam and you want to work very hard. So I wouldn't make it 48 hours as per 2 days. 2 days is too much. Give yourself 24 hours, one day. Make sure you learn all the functional groups of these homologs. Listen, if you learn these things, the functional group, you have gotten 80 to 90% knowledge of IUPAC nomenclature. I am assuring you that. IUPAC nomenclature is not all about the name. 1, 2,5, trimethyl, whatever. That is not the problem. The first problem is for you to be able to even identify the structure as per the homolog it belongs to. The other one that, okay, the name is 1,2 dimethyl pentane. These things are just procedure that someone can explain to you within 30 minutes. You've grabbed all this knowledge. You've understood that. Are you following? So this is your first key point to give serious attention to. So I said that this gives you a high level knowledge of IUPAC nomenclature. If you learn this functional group, you have gotten 70% knowledge of the chemical reactions of these homologs. And what else? Nothing more. That's why you don't joke with them. And I guess I have done well on this. Should I just write one structure on the board? But I am not really interested in teaching you IUPAC nomenclature today. But let me just bring out one structure as we close. Let me bring out one structure. There are still some other things I need to explain to you, but don't worry. In our next class, step by step, we'll deal with how to name these guys. But before then, you can still help yourself, because I might still decide not to teach the step-by-step approach. I have a video lesson dedicated to the step-by-step analysis on how to name compounds. So in fact, when I teach you organic chemistry in my next class, I wouldn't overstress myself talking about those step-by-step approach. You call them rules, you know that better. So make sure you go take that lesson, please. It's a 40-minute lesson on the GMAETS 41's, this particular channel, Chem 102 playlist. If you go to that playlist, that's the first video lesson you would see there. Is that okay? So I have this structure here. This is what I've got. I'd like us to just give the IUPAC nomenclature. So we have 1, 2, 3, 4. 1, 2, 3, 4. Then here we have HO. It can be written as HO or OH. From the question here is HO that was written. Then H, have this. We have this. Something like this. Okay, this is BR. Then we've got this. Do well to take that lesson, please, so that you reduce my stress in the main class where I teach you IUPAC nomenclature, because that's the next thing that we follow after today's introductory class. We want to name this guy based on the options provided here. Based on the options provided, this guy was named respecting. I don't want to tell you what it was named respecting. I don't want to tell you. But I want us to look at this. If you look at the carbon atoms between them, the bond between the carbon atom is single bond, single bond. For that reason, we can refer to this compound as being an alkane. So I can really name this compound as an alkane. And if this compound is an alkane, any other atom or group of atoms that is not hydrogen becomes a substituent. So this OH will be a substituent, chlorine here will be a substituent, bromine will be a substituent. That is if I am taking this to be an alkane. Sadly, in the question, the options were not given respecting this as an alkane. It wasn't given respecting it as an alkane. And of course, they have their reason, which is correct with respect to what we know about IUPAC nomenclature. Now, look at this. Do you know the presence of this OH? What does that tell you this homolog can still be? The presence of those OH. You can get your answer from here. Somebody can drop the answer to that. The fact that this compound contains OH, what does that tell you? If you don't want to name it as an alkane, can you still name it as another homolog? Someone should please drop the answer. I am looking at this. Someone should drop the answer. Can you name it as another homolog apart from saying that, okay, this can be an alkane? Because it can be an alkane, single bond between a carbon atom. But based on this OH, can you name this compound as another homolog? As someone drops the answer? No one has yet. Okay, so I think I'm going to proceed. Is network disturbing you people? Let me see. Okay, so wait. So I asked. Good, that's good. Ngacha Ange. Ngacha Ange, you are very correct. You are very correct. You are very correct. You can name this as an alkanol. You can name this as an alkanol. And I'm going to give you a gift. I'm going to give you 500 units worth of airtime. All right? Ngacha Ange, I'm going to give you 500 units worth of airtime. How do you claim it? Send a message to me on WhatsApp. This is the number you would use. Tell me your name as you have here. If you send a message, I might ask you 1 or 2 questions to be sure you are the one. Then I would forward the 500 units airtime to you. That's correct. So we can name this as an alkanol. And of course, that was the part that the examiners went through in the option. Listen to the option before I give the name of this, and then we close for tonight. Option A, 2-bromo 3-chlorobutanol. 2-bromo 3-chlorobutanol. You can hear that butanol, no, alkanol, oh. So, and this is one thing unique about the suffix of these guys. Alkanes, all of them will end in n. Alkenes, all of them will end in in. Alkynes in ein. Alkanols in all. Alkanals in al. Alkanones in o. Alkanoic acid in oic acid. Esters, alkanoids in OH, because that's how you call them, OH. You hear something like ethyl ethanoids, right? Okay, halogenal alkanes, halogenal alkanes is simply alkyl halide, or you can call them halogenal alkane fully as it is. Like I gave you one example, bromopropane, are you following? Or propyl bromide, and that's it. So for this alkanol, however you name it, it's going to end with the parent of alkanol. So that's option A, 2-bromo 3-chlorobutanol. Option B is 3-bromo 2-chlorobutanol. Option C is 3-chloro 2-bromobutanol. Option D is 2-chloro 3-bromobutanol. So you see that the examiner provided options that respected this structure as an alkanol. Therefore, we are going to handle it in that way. And it is still correct, even though this guy can have a name which respects alkane, a parent name that respects alkane, due to the fact that all the carbon atoms are linked by single bond. In that case, this will become attachment, or you call them substituent. But based on the option, we can still call this an alkanol because of this OH, and it's still correct. So if I take this as an alkanol, the next thing I will do is to determine the longest chain. And what is the longest carbon chain here? If you look at this, clearly 4. 1, 2, 3, 4. Or 1, 2, 3, 4. The longest carbon chain, determine it. You can see it very clear. This is a simple structure. It does not mean that you have anything difficult structure. Come on, nothing is difficult. This is simple. Okay? Now, the next thing you have to do is, where will you start your counting from? You know that the longest chain is 4. But where will you start the counting from? Will it be from 1, 2, 3, 4, left to right? Or will you start from right to left? For alkanol and for this structure as it is, the counting will start from the side closest to the OH. The counting will start from the side closest to the functional group. The functional group of alkanol is the OH. The OH is closer to the left-hand side. So the counting will start from the left-hand side going to the right-hand side. Therefore, this is going to be 1, 2, 3, 4. Remember, like I said, there are much other rules, right? Approach that I'm going to teach you as we move on. But do well to take that 40 minutes video, like I said. Go to the playlist on this channel. Chem 102, you'll see that video. It is actually on IUPAC nomenclature of alkane, because that is where I finished all the rules you need, which will now guide you through all other homologs. Okay, so let's go. Now, 4 carbon atom is boot. 4 carbon atom is what? Boot. And then if you come to all this homolog like in alkane, because that's the starting point also, you have to treat these guys as IUPAC nomenclature, start with alkane. The first member is methane, so let's go mention it up to number 10. But in WAEC and JAMB, you're only going to be tested in IUPAC nomenclature up to 6 carbon atom. The first one is methane, ethane, propane, butane. 4 carbon atom, butane. So your interest is the prefix. The ending part of the name, the suffix, is similar to the homolog name. Number 5 is pentane. Number 6 is hexane. 7 heptane, 8 octane, 9 nonane, 10 decane. You know, from number 5, pentane, hexane, heptane, octane, nonane, decane. It follows polygon. You know, polygon from number 5 is pentagon. After that, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon. Now remove the argon, and follow up with the suffix of this formula. So you have from number 5 pentane, number 6 hexane. If it is alkanol, it will now become number 5 pentanol, 6 hexanol, 9 will be nonanol, number 4 will be butanol, in that order. So 4 carbon atom alkanol is called butanol. So however you name this thing, the parent name, which will be the last part of the IUPAC nomenclature, will be butanol. Have that in mind. Now let us identify the attachments. Remember, the parent name is being given respecting this. So this is no longer an attachment, the OH. The attachments now are this and this. Attachment or substituents are any other atom or group which is not hydrogen and is not counted among the parent carbon. Chlorine is not carbon, so it's not counted among the parent carbon. The parent carbon is just this 1, 2, 3, 4. This was not counted among the parent. This was not counted among the parent. And chlorine is not hydrogen. Bromine is not hydrogen. This is how we get to know that this is an attachment. This is an attachment, also called substituent. OH here is not an attachment. This is what identifies this compound for us as an alkanol. So we are now going to analyze the name of their substituent. Chlorine is called chloro. Bromine is called bromo. Now if you look at chloro and bromo in alphabetical order, because they use alphabetization rule, in alphabetical order, using the initial, the first letter of this name. This is chloro, C. This is bromo, B. B comes before C in alphabetization, alphabet ordering. B comes before C. So if you are mentioning this attachment, you are going to mention bromo before chloro. You're going to mention bromo before chloro because of alphabetization, order of arrangement of the alphabet. You use the first letter of the alphabet. I hope you are following what we are analyzing, right? So concluding this, we are now going to move on. On the third carbon atom of the parent, you have bromo attachment. That's going to be 3 bromo. Between number and alphabet, you put hyphen. Then if you have number following each other, you put comma. All those things, you meet them as we move on. On the third carbon atom, you must indicate the position of the parent carbon bearing the attachment you want to mention. On the third carbon atom, you have bromo attachment. On the second carbon atom, you have chloro attachment. There is no other attachment again. So you conclude with the parent name. 4 carbon atom is but. OH tells us that it is alkanol. Number 4 but in alkanol is butanol. So this becomes chlorobutanol. This is actually butan 1-or. Butan 1-or. But if the OH is on the first carbon atom, we don't really bother ourselves indicating 1-or. But in case you see this, take note. Or this is butan 1-or to indicate the carbon atom bearing the OH. The carbon atom bearing the functional group. But like I said, if the OH is on the first carbon atom, you can just go straight as alkanol, like in this case, butanol. But if it's the parent carbon bearing that functional group OH, which is on number 1, therefore you break the alkanol to alkan something or. That's something that is the position of the carbon bearing the OH. If the OH is not on the first carbon atom, if the OH is not on the first carbon atom, you can't present the parent name like this. It must follow this format. Let us assume that the OH is on the second carbon atom. You can't say butanol. It will be wrong. The correct thing will be butan 2-or. That's why I showed you this or, so you watch out for it. All right, guys. Think we are done with what I want you to know today. We've spent a lot of time, 2 hours. But of course, the 2 hours is worth it. The 2 hours is what? Worth it. Do you get that right? Frozen, you said, sir, is it a must that we use alphabetical order rule stuff? Let's see. I couldn't read that. It disappeared. Let me check through. Okay. Let me check through your question. Is it a must? Did you delete your question? Someone frozen, you deleted it. Okay. So I am safe from responding to your question. But if I saw some part of what you asked earlier, it's a must. You must follow that alphabetization. That is one rule that you do not exclude when giving Ayupak names. All right, Queen Oma, left to right, you are very correct. I got a question, Uditi Chiba. What is your question, please? You can ask your question quickly because I'm about to close the class. We have spent more than enough time. Frozen, you've brought the question again, sir. Is it a must that we should use alphabetical order? Yes. You don't play with that. Whenever you want to name the attachment, because in giving the Ayupak nomenclature, you come up with the names of the attachment first, then conclude with the parent name based on the longest carbon chain. When you are presenting the substituent name, the attachment, the order you follow, it must be alphabetical. If you look at this, chlorine was on second carbon atom, bromine was on third. On the normal, somebody will say, you have to pass 2 before 3 now. But you don't do that. You must follow alphabetization to help you know the order in which you pronounce or write the substituent. All right, so please, as we come to this, we want to be mindful of what we post. Remember, YouTube has got their policies. I wouldn't want to tolerate any one of you who posts anything that is suspicious here as you post. Uditi Chiba, how much crack do you sell today? I don't understand what you mean by that. At least from my little knowledge of English language, that term crack is, please, if it is what I used to hear people associate this with, be careful. Don't you post something like that again on this channel. I will ban you. Take note of that. Okay, so we are done about that. Uditi, be warned. I am warning you. I am going to anyway, I will block you. I'll block you. Don't talk drugs here. What's the problem? This is an academic channel. I've blocked you and I might block you completely from my channel if you're not careful. Please, all of you who post comments here, this is specifically an academic channel. I don't talk shit when I come here online. My purpose is to teach people and leave. Be careful of what you post. Okay, so that is it. Thank you for all of you who respect the purpose of this online channel. And for those who disrespect that, I'm watching you. I can always block you from this channel straight on. Don't come and cause a problem to this wonderful channel dedicated to giving students the best at all times. All right, guys. Thank you for tuning into this class. It's been a wonderful one. We have covered the concept of solubility and key introductory concepts of organic chemistry. In fact, with what we've done in organic chemistry, I must tell you, it's as good as if we have covered 60%, yes, of organic chemistry. Be assured of this, I've told you. I'll be seeing you tomorrow morning by God's willing, 7 o'clock a.m. Yeah, because let me see, this is 11:37, 7 o'clock a.m. I'm going to make it 7:30, please, because I need to sleep, right? 7:30, we'll have a class from 7:30 to 8. It's going to be English, like I said. Consonant, we have questions we're going to answer. The live class by 7 a.m. tomorrow morning, Nigerian time, will not be on this channel. It won't be on this channel. Our English class takes place in the GMAETS 41's basic class channel. So you can type on this, type this now and go subscribe to the channel. Tomorrow in the morning, I'm going to handle that class. And then in the evening, we'll look at another subject. Like I said, I'll be coming on live tomorrow evening by 8 p.m. Either 7 p.m. or 8 p.m. Yeah, 8 p.m. We'll be dealing with mathematics. Okay, JAM and WAEC maths. Good night and take very good care of yourself. Enjoy your sleep. And if you must dream, I am going to condition you on what to dream about. You have to dream of solubility. You have to dream of organic chemistry. You have to dream of GMAETS 41. Dream, see yourself in examination hall, blasting the questions provided with super result in view. Good night, guys.